When you hammer an iron nail, you apply force on the flat side of the nail. The pointed side of the nail, which is in contact with the wall, then applies the force on the wall and tries to pierce it. Now let me ask you an interesting question. What will happen if you hammer the pointed side and try to pierce the flat side of the nail? You will find it difficult to push the flat face of the nail through the wall even if you apply more force than you did in the first case. What is the reason for this? The reason is that the pressure applied by the tip of the nail on the wall is more than the pressure applied by the nail's flat surface. But the question is why? First, notice that the area of the tip of the nail is very less as compared to the area of its flat surface. This tells us that the area of the surface on which the force is applied matters. We will understand this in detail, but first let us define pressure. We define pressure as the perpendicular force acting on the surface of an object per unit area on which it's acting. It's easy. Force acting per unit area. We already know that the SI unit of force is Newton, denoted by N, and that of the area is meter squared. So the SI unit of pressure is Newton per meter squared. It is also called Pascal, which is denoted by PA. Why is it called Pascal? It is given this name to honor the achievements of a French scientist named Blaise Pascal for his contributions in hydrostatics and hydrodynamics. Observe the equation carefully. Area is in the denominator of the fraction. What is this area? Well, this area is nothing but the area on which force is applied. Say I keep the force constant and I keep increasing this area. What will happen to the pressure? Will the pressure increase or decrease? Use pure mathematical logic to answer this. If I have a fraction and I keep the term in the numerator constant and keep increasing the term in the denominator, then will the fraction increase or decrease? Surely it will decrease. So the pressure will decrease if I increase the area while keeping the force constant.